So I left this example off the other video because you didn't really need it for the check for understanding, for the mastery check. But it is just kind of a cool thing that you can do. So if you have 3 points on a quadratic parabola, on the graph of the parabola, you can actually use those 3 points to find the actual equation. So what we can do is plug in each point for x and y. So the equation is y equals ax squared plus bx plus c. So if I plug the first one in, 3 goes in for y, and 1 goes in for x. Now if I simplify that, I get 3 equals a plus b plus c. Now let's take the next point. Negative 1 goes in for y. 3 goes in for x. And I'll simplify that and get 9a plus 3b plus c. The last point. Now, what's really nice is the fact of your c doesn't have a coefficient because c is a constant. So if I take equation like 1, or let's say equation 3 and subtract equation 1. Equation 3 and do minus equation 1. So take equation 3 just like it is and do negative equation 1. The c's will cancel. I'm going to do the same thing with equation 2 and equation 1. So equation 2 now I have 2 new equations, and I'm going to write them. Actually, wow, I could divide that equation by 3, couldn't I? So I get 5a plus b equals negative 1. If I divide that equation by 2, oh, that's kind of nice. I'm going to take that equation times negative 1. Now, as long as you're doing it to both sides of the equation, you are not doing anything illegal. And I get a equals 1. So if I plug in 1 for a, I now have that b is negative 6. Go back to the very first equation. Negative 5, c equals 8. I end up finding the exact quadratic. This is actually more exact than like the linear regressions you might have done in your Algebra 2 class.